Leo, a young puzzle master, was diving into a book about space travel when a number stopped him in his tracks. The speed of light. If I'm on a spaceship and I throw a ball forward, the ball goes faster than the spaceship, right? So, why does everyone say nothing can go faster than light? Just then, the air in his room shimmered, and a woman in a lab coat dotted with star charts appeared with a friendly smile. Welcome to the universe of flexible rules. Leo, your common sense is spot on. Usually, speeds add up. But a genius named Einstein discovered that the speed of light isn't just fast. It's the ultimate unbreakable speed limit of the entire universe. This was Professor Stella, and she was about to take Leo on an incredible journey. She conjured a holographic projection of a race. Two runners, Alice and Bob, stood ready. Imagine Alice is standing still, she began, and Bob is running incredibly fast, almost at the speed of light. Now, if they both switch on a flashlight, something amazing happens. The light from both flashlights travels at the exact same speed. Leo was baffled, but that breaks the rules of math. Bob's light should be faster because he's already moving forward. Professor Stellar grinned. Exactly. And since the speed of light refuses to change, the universe has to get creative. It adjusts the only other things it can: time and space. As Bob's holographic image accelerated, his stopwatch began to tick slower and slower, and his body appeared slightly squashed. To make the math work out, she explained, Bob's time slows down and his space compresses. If he traveled at near light speed for just 1 year and returned, everyone on Earth would be much, much older than him. Time isn't a fixed clock. It's more like a flexible rubber band. Next, Professor Stellar changed the scene. Now, they were looking at a giant, invisible fabric stretched across the cosmos. Now, Leo, forget everything you think you know about gravity being a force. Einstein imagined the universe as this giant, flexible fabrica cosmic trampoline. A heavy bowling ball labeled the sun dropped onto the fabric, creating a massive, deep dip. Wow, Leo exclaimed. The sun creates a huge sag. Precisely, the professor said. Now, watch what happens when the Earth, this little golf ball, rolls nearby. The golf ball didn't get pulled by some invisible string. It simply rolled straight into the curve created by the sun, beginning to circle around it. The Earth isn't being pulled, she continued. It's just following the shortest, straightest path possible through a curved space. That curve is what we feel as gravity. Leo stared, his mind buzzing. So, time and space aren't fixed. They change based on my speed. And gravity isn't a pole. It's just the shape of the universe itself. Professor Stellar clapped her hands. You've got it, Leo. You've just understood relativity. You've learned that time and space aren't a static stage. They are active, flexible players in the grand cosmic play, bending and stretching depending on speed and mass. The universe is so much more wonderfully strange than we can imagine. If you enjoyed this trip through spacetime, don't forget to like, subscribe, and hit that notification bell for more cosmic adventures. Thanks for watching.